In this part of laws of motion, you will study about angle of friction and angle of repose and the relation between them. Angle of friction. The angle of friction is the angle which the resultant of limiting frictional force and the normal reaction makes with the normal reaction. As shown in the figure, W means M into G is the weight of the body, N is the normal reaction, F max is the limiting friction, capital F is the applied force, then by the definition of angle of friction, lambda is the angle made by the normal reaction and resultant of frictional force and normal reaction from the triangle. Tangent lambda will be equals to small f, the frictional force, upon the normal reaction. But you know that the F max divided by N is what? In place of F max, you can write mu s into N. So you will get mu s N by N, and the N is cancelled. So the lambda will be maximum will be equals to tangent inverse mu s. Or you can say that the coefficient of static frictional force is equal to the tangent of the angle of frictional force. Angle of repose. It is the minimum angle that an inclined plane makes with the horizontal when a body placed on it just begins to slide down. As shown in the figure, consider a body of mass m placed on an inclined plane. The angle of inclination theta of the inclined plane is so adjusted that a body placed on it just begins to slide down. Thus, theta is the angle of repose. Various forces acting on the body in this situation are weight mg of the body acting vertically downward, limiting frictional force in upward direction along the inclined plane. It balances the component mg sine theta of the weight mg along the inclined plane. Thus, you can say that Fs maximum is equals to mg sine theta. The normal reaction N perpendicular to the inclined plane, it balances the component mg cos theta of the weight mg perpendicular to the inclined plane. Thus, N will be equals to mg cos theta. And when the body is just about to slide, mg sine theta will be equals to Fs max, and the value of Fs max is mu s into N. By putting the value of N mg cos theta, mg will be cancelled out and the tangent theta will be equals to mu s. Or you can say theta is equals to tangent inverse mu s. Thus, the coefficient of static friction is equals to the tangent of the angle of repose. Here, we have taken the maximum value. So you have to take care that the angle of repose is equals to maximum value of angle of friction. Now let's apply this knowledge in different situations. Firstly, the body is kept on a horizontal plane and is at rest position and no force is applied. For this, in the vertical equilibrium, frictional force is 0 because frictional force is an opposing force and there is no external applied force. And the normal reaction N will be equals to M into G. Second case, when the body is kept on the horizontal plane and it is at rest under single horizontal force. So again, for vertical equilibrium, N will be equals to mg since the body is at rest, and for horizontal equilibrium, as the body is at rest, that means the applied force will be equals to the Fs, means the static frictional force. Third case, body kept on horizontal plane is just about to move. For vertical direction, N will be equals to mg, and for horizontal direction, F will be equals to Fs max, and that is equals to mu s into N. Body kept on horizontal plane is accelerating horizontally. For vertical direction, N will be equals to mg, and for horizontal direction, F minus mu k N will be equals to ma, the net force. In this case, the body kept on horizontal plane is accelerating horizontally towards right under single upward inclined force, capital F. And if you resolve this force, you will get two components, F cos theta along the horizontal direction and F sin theta along the vertical direction. Now the two forces, capital N and F sin theta, are acting vertically upward and weight is vertically downward. So N plus F sin theta will balance the weight mg, and for horizontal direction, the net force is towards the positive x-axis. So F cos theta minus Fk will be equals to ma. Or you can say that F cos theta minus mu k into N will be equals to ma. Now for inclined plane, case 1, body is at rest on the inclined plane. So perpendicular to the plane, there is normal reaction and that will balance the weight component mg cos theta, because vertically the body is at rest, and for the parallel to the plane, mg sin theta will be equals to Fs. Case 2, body is accelerating downwards on an inclined plane. So perpendicular to the plane, again N is equals to mg cos theta, because vertically in motion the body is at rest, and parallel to the plane, mg sin theta minus Fk will give you the net force ma, and by putting the value of Fk mu k n, you will get the equation mg sin theta minus mu k n will be equals to ma. For third case, the body is accelerating up the inclined plane under the effect of force acting parallel to the incline. For vertical, N will be equals to mg cos theta, and for parallel to the plane, the capital F minus Fk minus mg sin theta will be equals to ma. Now, a numerical. A mass of 4 kg rests on a horizontal plane. The plane is gradually inclined until at an angle of 15 degree, With the horizontal, the mass just begins to slide. What is the coefficient of static friction between the block and the surface? Again, writing the balancing equations, mg sin theta will be equals to fs and mg cos theta will be equals to n. As theta increases, the self-adjusting frictional force increases up to the theta max, and at this value fs max will be equals to mu s n, and you know that it will be the tangent theta max, and the theta max will be equals to tangent inverse mu s, and the value of theta max is 15 degree, so the mu s will be equals to tangent 15 and that will be 0.27. Thank you.